Hello ladies and gentlemen, this is the Chemistry June 2017 Regents, in which I'm going to go through all 4 parts of this entire exam. And this video starts with part A. This is my first time actually doing a full Chemistry Regents on video. And my specialty is physics, and I've done those in the past, but this should be an interesting experience. But much like physics, part A is 35 multiple choice questions. Part B, 1, is the other 15 multiple choice questions. Part B2 is the start of the free response section, and Part C is also another. So Part C is more of grouped free response. Part B2 is kind of like various free response questions. They're not necessarily grouped together by topic. They're more like here and there, whatever questions. And we're going to start with Part A on the next slide. Part A has all 35 multiple choice questions. Some of them are more content based, whereas Part B1 is a little bit more mathematically involved, as I've noticed. And we're going to start with number 1 here. Let me zoom in for a bit. Alright, I'm going to leave a lot of blank space here for work and explanations. I know this is very common in physics, but we'll see if I need this for chem. Alright, so we start with number 1. Which statement describes the structure of an atom? So, our basic model of the atom should be involving something in the center called the nucleus, and then around that are small negatively charged particles in some weird cloud formation. And inside this nucleus are going to be positively and neutrally charged particles and stuff. So right here is going to be our nucleus. And then this here are electrons. And so here, which statement describes this? Nucleus contains positively charged protons while it's surrounded by negative charges. And that's choice 3. Number 2, which term is defined as the region in an atom where an electron is most likely to be located, and that's an orbital. So our more recent models of the atom kind of talks about the probable locations of electrons, and we imagine it as sort of this cloud-like region where the denser the cloud, the more likely an electron's going to be, like in here. So this means more electrons will be here versus kind of sparsely located here and there. They're less likely to be, whereas dense clouds mean probable locations, less dense means less probable. And that's what we call an orbital. And that's something we just need to know by definition, and it's a commonly asked question, by the way. Anyway, number 3. What is the number of electrons in an atom of scandium? So, for number 3, number of electrons in an atom equals number of protons, unless you're talking about an ion, which is equal to the atomic number. So you gotta look up scandium. Scandium has the element symbol of Sc. And Sc has an atomic number of 21, and so that means the number of electrons is 21. Number 4, which particle has the least mass? And if we look at each of our choices, helium atom has more than 1 proton and neutron. So it's definitely the biggest. Proton in a hydrogen atom also happen to be the same because there are barely any neutrons in there. Actually, most commonly there are no neutrons, so it's just a proton. And so that leaves us with an electron. The electron has very negligible mass. We practically consider it 0 atomic mass units. Number 5, which electron transition results in a release of energy? Okay, so for number 5, release of energy means you're going from a high state to a low state. Or not necessarily state, but level. whereas absorption means you're going from low to high. So since we're looking for a release of energy, we need to go from a high to a low, and the only one that fits that is choice 4. Okay, number 6. The number of protons is indicated by its atomic number. So a lot of these questions you just need to know by definition, and they're actually pretty straightforward like that. Alright, which type of formula shows an element symbol for each atom and a line for each bond between atoms? So let's think about a formula like this. This is the molecular formula. And what it's asking for that shows the element symbol for each atom and a line for each of them to show the bonds. So something like this is what we call the structural formula. This from the first one is a molecular formula. This can also be considered an empirical because it's in the reduced form. But the difference here, if you want a strictly molecular formula, then it would be this. Reduce it further in simplest ratios, then you would get the empirical. So this one is strictly molecular. Number 8. What is conserved during all chemical reactions? Charge is one of them. The conservation laws in chemical reactions all deal with mass and charge and sometimes energy. Okay? So conservation of mass, charge, and energy are definitely exhibited in chemical reactions. Alright, number 9. In which type of reaction can two compounds exchange ions to form two different compounds? Okay, that is a double replacement. So when two compounds exchange ions, so what we mean by that, let me show you an example. So I just took a very simple example of two salts exchanging ions. So this is what we call a double replacement. So here, the Li and the Na, lithium and sodium, swap partners. So now Li is paired up with Br, and Na is paired up with Cl, which we could see as a result in the product side of the reaction. So that's what we mean by exchange of ions. Okay, where these guys swap to become that on the other side. And that's what we call a double replacement. Single replacement is if you have one element coming in to swap positions with another element, and that one that's swapped out becomes a lone element. Okay? Decomposition, you're taking a compound and breaking it into its two elements. Synthesis is the reverse, taking two elements and combining it together to create a compound. And number 10, at STP, 2 5-gram solid samples of different ionic compounds have the same density. These solid samples could be differentiated by their what? So it's definitely not mass because they are both 5 grams. So I'm going to split this up into sample A and sample B. They're both 5 grams each. They have the same density. So by virtue of that, because of both same mass, same density, they're also going to have the same volume. So it's not volume. At STP, because it's the same temperature surroundings, it's also the same temperature. The only thing that will be different because they're different ionic compounds will be their solubility in water. Okay? Some ionic compounds have different solubility levels in water, and it depends on the nature of that ion. But you could see, based on the evidence given in the problem, same mass, same density, so that means they have the same volume. It's at STP, so it's the same temperature. And the only thing that's not different here is their solubility, which we can eliminate based on the choices given. Number 11. What is the number of electrons shared between the atoms in an I2 molecule? So I2 has 2 iodine atoms that are joined together by a single bond, and the rest are all lone pairs for the full octet for each of them. And so when it says shared, we're talking about the bonds. So there's only one bond, and one bond equals 2 electrons. Okay, so that is choice 2 for 2 electrons. Number 12, which substance has nonpolar covalent bonds? So nonpolar covalent bonds usually occur in diatomic elements. And usually there's a good phrase to remember them. This is my phrase. You might have seen some different variations on the same phrase, but they're all the same elements, Honkel, Briff. So hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. And we can see that choice 1 has chlorine, that's in a diatomic element, and that has nonpolar bonds. Okay, choice 1. So nonpolar meaning that the electronegativity difference is very little, 0.4 or less, sometimes 0.4 might be counted, but here with diatomic elements, they have 0 electronegativity difference, so it's evenly spread throughout. The electrons are evenly shared between them. Okay, next is number 13. Compared to the potassium atom, a potassium ion has what? So potassium atom versus the potassium ion, which is K+. K has 19 electrons, whereas potassium ion has 18 electrons. It has lost an electron. So a good way to even think about this is that if we try to draw potassium in terms of the Bohr model, so there we have 4 energy levels. So we draw 4 rings, and each ring represents an energy level. So there's 2 in the first, there's 8, 8, and then 1 in the atom. If you remove 1 electron, you immediately remove the 4th energy level, so it becomes even smaller with just 3 rings. So in that case, the potassium ion, for all positive ions, will have a smaller radius. Okay, so you'll see here it's 288 for the K+ ion, and so it's smaller radius. Choice 1. You're never going to change protons because both of them are potassium, and the number of protons gives you the atomic number, which gives you the element. So you're never changing protons between atoms and ions. It's only the electrons, and that plays a role in how big it is. Which form of energy, for number 14, is associated with the random motion of particles in a gas? So motion, we equate to kinetic energy. Kinetic energy is related to temperature. And temperature, we often think of heat. And heat, we think of thermal energy. So it's a lot of word associations here, which helps us lead into the answer of thermal energy as our answer. Now, following up with that same idea, number 15, average kinetic energy. Kinetic energy, you look at temperature, so we're looking for when the average kinetic energy decreases. So we're looking for a decreasing temperature for the decrease in kinetic energy. And they're all given in Kelvin, so the only one that shows a decrease in temperature is choice 1. Number 16, the joule is a unit of energy, okay? This you could find on the reference table. This is on table D, which gives you the units and the quantities they represent, okay? Let's switch up the colors. Number 17, compared to a sample of helium at STP, the same sample of helium at a higher temperature and a lower pressure will do what? Well, let's see. So let's think. We're at a higher temperature. Is it going to condense to a liquid? No, this happens at lower temperature. More soluble in water. So helium is a gas. It's more soluble at lower temperature also. Gases favor lower temperatures. Think of soda. Soda is best when you have it cold. Forms diatomic molecules. So helium is a noble gas. Noble gases don't bond. Okay? So it's not choice 3 either. That leaves us with choice 4, which also follows with ideal gases. They exist under these conditions: low pressure, high temperature. Okay? So they're fast and random and moving a lot, but they also don't exert any forces. Okay? So that's why ideal gases prefer these conditions. So no forces practically with low pressure, and high temperature means fast and random motion, which is the motion of ideal gas particles. High, fast, random motion. Okay, continuing in the same line of gases, here we have a sample of gas in a sealed rigid container that maintains a constant volume. Which changes occur between the gas particles when the sample is heated? So when the sample is heated, temperature goes up. So when it starts to move fast, it's raising temperature, so it's having a lot of collisions, okay? So we're definitely going to see an increase in the collisions. But the force of these collisions should also increase. All right, so we're seeing an increase in collisions and force of collisions, frequency and force. Okay, number 19. At STP, which gaseous sample has the same number of molecules as 3 liters of N2 gas? So Avogadro's law. So if you want the same number of molecules, same number of moles, then you need same volume at STP. So we're looking for the same volume of N2, so 3 liters, and that's choice 3, the only one with the same amount of volume. All right, number 20. Change colors. Distillation of crude oil from various parts of the world yields different percentages of hydrocarbons. Which statement explains these different percentages? Okay, so we look at each of these. Okay. So my strategy is to look at each of these choices and eliminate. So choice 1, each component in a mixture has a different solubility in water. So what that statement is telling you is that with different solubilities, it only changes how you're going to obtain that component in a mixture. Some of them are really soluble, they break down, or some of them aren't really soluble, so you could easily filter it out as precipitate. So that only tells you the method of how you're going to obtain it, not really different percentages. So it's not choice 1. Choice 2, hydrocarbons are organic compounds. That doesn't really tell us much, to be honest. That only tells you what hydrocarbons are. It's not really an explanation for different percentages of them. Number 3, the carbons in hydrocarbons may be bonded in chains or rings. Again, that's almost stating some characteristics about it, so it's not necessarily an explanation. But number 4, choice 4, is our answer. But why? The proportions of components in a mixture can vary. So let's think about it this way. Let's think about a bag of Skittles, each of different colors. Alright, so when we compare these 2 different samples, let's imagine it as 2 different types of crude oil from 2 parts of the world. So here we can see there are a lot more reds and very little blues and just a fair amount of blue. This is actually green. Very little greens and a fair amount of blues. On the other sample, you see a lot of greens and barely any reds and still some blues, okay? So we can tell that definitely proportions of components can vary. So this one has a higher proportion of red, this one has a higher proportion of green, and so that will lead into different percentages for each type of Skittle, different color Skittles, different types of hydrocarbons for crude oil. So that's our answer for number 20. Wow, that took 2.5 minutes. 21. In which 1 gram sample are the particles arranged in a crystal structure? So you need to think about this as a solid. Which of these make solids? And that is choice 1. Solids are arranged in a crystal structure, especially ionic compounds, salts. They're arranged in crystal structures. At least they make it obvious enough that you pick out the solid. Number 22. When a reversible reaction is at equilibrium, the concentration of products and the concentration of reactants must be what? So concentration, they must be constant. So they don't have to necessarily have equal amounts, equal concentrations, but as long as the rates are equal for equilibrium. So rates are equal and concentrations are constant, then you're at equilibrium. Because with an equal rate going backwards and forwards, you're able to keep the same amount being produced and the same amount being used up. Okay. Number 23. In chemical reactions, the difference between the potential energy of the products and the potential energy of the reactants is equal to, so PE of products, whoa, what the heck was that? Oops, not equals, minus PE of reactants. This will give us our delta H. And what is delta H? That is our heat of reaction. So especially when you look at those potential energy diagrams, like these guys, it's good to remember that it's always the difference between products and reactants. Products go first. Number 24. What occurs when a catalyst is added to a chemical reaction? So the purpose of the catalyst is to reduce the activation energy. And how does it do it? By finding alternate pathway. So alternate reaction pathway with a lower activation energy, choice 1 is our answer. Okay, number 25. What is the name of the compound with the formula CH3, CH2, CH2, and H2? Alright, so key thing, this is an organic compound, and most importantly, there's the N. So we gotta look at table R for the name of this functional group. Okay, so I took a snippet of this from the reference table on the internet, and I only took parts of the table R that is necessary for this. Okay, so when there's a nitrogen, we should immediately think that it's gotta be amine or amide. So we could immediately cross off choice 1, propanol, that's an alcohol, and propanal, that's an aldehyde. So we're looking at propanamine or propanamide. Propanamine or propanamide. I can't even say these correctly. Okay, so let's look. The difference between that is that amides have oxygen, amines don't. So if we look at our formula, there's not a single oxygen here. So it's got to be the amine. And look here, it's the same exact example right here in our question. So it has to be choice 2. I'm not going to bother attempting to saying that. I get the syllables confused. Okay, so number 29, which compound is an isomer? So we got to think with isomers, same composition, just different arrangement. Different structure, different arrangement. So we're just looking at which one has the same, essentially the same number of atoms in its formula. Just rearranged differently, as you can see in the different order of the atoms in the formula. So let's look. So ultimately we're looking for a formula that has 4 carbons, 10 hydrogens, and 1 oxygen. So 4 carbons, 10 hydrogens, and 1 oxygen. So let's see. Choice 1 is not correct. Choice 2 is not correct. Choice 3 is not correct. And it's actually choice 4, because there are also 4 carbons, 10 hydrogens, and 1 oxygen. And that makes it an isomer, just rearranged differently. Okay, 27. Ethanoic acid and 1-butanol can react to produce water and a compound classified as what? So this is a type of organic reaction you kind of need to know. But ethanoic acid is an organic acid, and butanol is an alcohol. When you combine an organic acid and an alcohol, you make water and an ester. And this process is called esterification. So when you combine an organic acid with an alcohol, I can't even spell. Wow. Esterification. That's what happens when I'm writing too fast. So this makes an ester. 28. During an oxidation reduction reaction, otherwise known as redox, the number of electrons gained has to be equal. We're talking about conservation of charge in any reaction, conservation of charge. Number of electrons gained equals the number of electrons lost. When someone loses, someone else has to gain those electrons, okay? So it's a complete transfer of electrons from one element to another. Number 29. Which process requires energy for a non-spontaneous redox reaction to occur? So you need energy for this, and that's electrolysis. Electrolysis requires the use of a battery to make the reaction happen. So the electrolytic cell requires a battery. Okay, number 30. Which pair of compounds represents one Arrhenius acid and one Arrhenius base? So these guys you can look up on the reference table actually. And that's on table K and table L. So I'm going to pull them up in a bit. Alright, so here's our table K and L for the acids and bases. So we need to see which of these has a pair of an acid and a base. Let's look at each of them. Choice 1, CH3OH, happens to not be an acid, but NaOH is an acid, so you need both of them present. That's not it. Choice 2, CH3OH, again, that's neither one of them. HNO3, that's a valid acid. NaOH is a valid base, so yes. And just to make sure, choice 4, HNO3 and HCl are both acids, so both are not valid.